Here we're going to use the graph of f of x equals the cube root of x to generate the graph of g of x equals the cube root of negative x. So we need to start by graphing f of x equals the cube root of x. This is another one of our common functions that we would like to have some type of familiarity with. And so normally with these common functions we can plug in values for x like -2, -1, 0, 1, and 2. Now -2, if I plug it in there, I'd get the cube root of -2, and certainly I could approximate that with my calculator, but it doesn't work out to a nice value that would be easy for me to plot. So I want to maybe start with something a little more convenient. And the cube root of -8 would work out nicely. That actually comes out to -2. And then I could use the same values for this middle section of -1, 0, and 1, because all of those cube roots work out nicely. Then I can go ahead and plug in a +8 for the last one. So the cube root of -1 is -1, cube root of 0 is 0, cube root of 1 is 1, and the cube root of 8 is 2. So let's go ahead and plot these points to see the graph of the cube root of x. So we want to go ahead and connect these points here with a curve. So that's essentially the general shape there of the cube root of x function. And so now we want to use that to get a graph of g of x, which is a cube root of -x. And in order to do that, we need to know what type of transformation is being indicated by having that -x in there. So anytime we have a negative multiple, that's going to result in a reflection. So it's either going to be a reflection over the x-axis or a reflection over the y-axis. So to tell the difference, we look at the fact that the negative is attached directly to the x. So we're taking the opposite of an x-coordinate. It's not on the outside. If it was on the outside, that would be like taking the opposite of a y-coordinate, because all of our old y-coordinates we found by evaluating the cube root of x. But our negative is here inside, attached straight to the x. So if I, for an example, picked one of these points, let's say this point 8, 2, and I kept the y-coordinate the same, but I went ahead and took the opposite of the x-coordinate, which is what's being indicated here, I'd end up over here at -8, 2. And moving that point from 8, 2 to -8, 2 is a reflection over the y-axis. So that negative in there is indicating a reflection over the y-axis. So we're going to go ahead and take the rest of our points and reflect them over the y-axis also. So this point will come here. The point there at the origin would stay there since it's already on the y-axis. And reflect over the y and reflect over the y. And then go ahead and sketch those in with that same type of shape to complete the graph. Now just as a double check to make sure that we have plotted these points correctly, we can pick one of the points. Let me go ahead and use that one that's labeled at -8, 2 and go to our function g. So this -8, 2 has an x-coordinate of -8. So if I plug a -8 in for x here, I would have -8. So that's +8. The cube root of +8 is +2. So this point is consistent with our equation for that function.